Okay, hello students. This is the second problem of application of real life modeling into a trigonometric function. This is about Ferris wheel. You see, I modeled this, drawn a picture there. In the beginning, Tom is at this place in the beginning, and then he's at the height of 5 meters, and then the Ferris wheel rotates around in the counterclockwise direction, so that each second passed by, so this will have a height from the ground. So Tom's height ht above the ground in meters in time, t seconds is given. Now watch this graph. The graph is showing us that in the beginning this is 5, so what does this basically mean? Tom is in the beginning is at the height of 5 meters above the ground, and then as the time passes by, his height going on increasing. Okay, and so this is the minimum. The maximum it goes is after 20 seconds, he reaches 25 meters above the ground, and then it goes back to the same original place, which is, so it takes around 40 seconds for the whole complete cycle. And then I try to show this with the actual model of the Ferris wheel here. If you see this and compare this, that means the beginning, if Tom is right here, so it takes 40 seconds to reach to the same height. So what has happened in between is, in 20 seconds, Tom is right on, that's the maximum Tom is, and then that means in the next 20 seconds again it comes back to the same. So here, this is where it starts, and then in 10 seconds, so he will be at a height of what? That's the midline that we are talking about. So we have to first figure out what are the things required to complete this problem is, we need to know what is the k. So the first thing is, let's find out what is k, what is the midline. So this is the midline. So k, first, step number 1, find k. K is maximum plus minimum divided by 2. So the maximum it goes is until 25. The minimum is 5. So just do regular math. 25 plus 5 divided by 2, and k is 15. That means the midline, you can see this clearly. This is the middle line, which is 15 right here. And I can also draw a line through this. So this one is the midline. Okay. So that means this point. So there are points here too. So first step is we found the midline k. The second step is we also need to know what is the amplitude, right? So this is the midline. The amplitude is absolute value of A. Now in this case, it's maximum minus minimum divided by 2. So the maximum is 25 minus the minimum. If you work this out, you get 10. So what that basically means is, from this point, this is the 10. So it's so the amplitude is the distance from the maximum to the midline. Now, so we are done with the first part. We are done with this one. We do know this one, and the second thing is, what is the B? Now B is the how long does it take to complete one cycle. So if we start from here, it goes back there, because when Tom is right here, so for him to go back to the same height, it takes 40 seconds. So that means the period is 40. So we need to figure out what is that B. So B is, the period of sine function is 2 pi. So 2 pi divided by 40. So in order to figure out the B, it is 2 pi divided by t. T is the period. This is the period. So if you want to figure out what is that B, it's t, which is in this case it takes 40 seconds. So I plug it in here and you get pi by 20. And the last part is the phase shift. What is that? Phase shift. So in this problem, we can think that since he begins from here down, so start from down and then goes up. So in this, so this is the case. If you start from here, t equals 0, and then goes back and takes 40 seconds. That means this one is if this is the midline. Just imagine if the same problem was like this. Storm is right here, and then he rotates this way. Then this graph will be, it would go this way. So this would be the graph if Tom starts from the maximum, then this height goes on decreasing, goes to minimum, and then again back to. So in this case, this would be the cosine graph start from here with a positive. So this would have been plus whatever the amplitude was A, right? So it starts 10 cosine. But because it starts from down, so we will have to change these two. So this function will change to the ht equals, because it starts from down, it's a minus 10 amplitude, and cosine of b. So the b, so either you can use this or you can use cosine of b x minus h plus k. Now in this example, I'm using the b as a is negative 10, so this becomes b is right here, so pi by 20, and x minus, in this case we begin from t equals 0, so this will be 0, and plus k, the midline, this is that y equals 15, so we get 15. So this is one of the trigonometric function that we can model for the given situation. The question is, are there more cases also? What if we start from this point, which is after 10 seconds, and there is 15, everything changes. So this height, if I begin from this point, this starts from 0, so that's like a sine graph. So this will be plus 10 sine of pi over 20 x minus, so your starting is, the phase shift is 10, so that's where you go. So this will be 10, the rest everything stays the same, correct? Or we could have another equation, that's the last one. We could also write ht equals, what if I, instead of beginning from this point, you can start from this point, and that is at 20. So we said that's the graph sine graph. So this is like a cosine graph, start from top down. So this is this one. So if we use this graph, that will be ht of, since you are starting from top, it's going to be positive 10 and cosine pi by 20, and then x minus, so your phase shift right now is after t seconds, so 20 and plus 15. All this now, how do we, are we sure we are correct? Do we really know that these three trigonometric functions mean the same thing? So what I'm going to do is put it on the decimal calculator and see that this is true. Okay, let's check it out here, right here. So the one that we have, the one that we see is the tan cosine. So this is the one, tan cosine. The blue color, the graph that you see is this one. And now I have those equations. Look at this. So the green color is this one. The minus tan cosine pi. So this graph, ht is, if I click here and take off this green, and it's the purple color. So this is the same graph. Then the next one I use is tan of this one. And this one, let me take this off, click on it, and that becomes the orange. What I'm trying to say, all this, so there's no graph here, So this equation is the same as this equation, is the same as this equation. All three give you the same answers. So it's like creating, depending on the phase shift, where do you want to start. So the first one I started from down up this way, so I used the cosine trigonometric function. For the second one I used from here, so then it is like a sine shifted after 10 seconds there. And the last one I used from top, cosine graph. So all these three trigonometric functions represent the same height of Mr. Tom, who is revolving or rotating on the Ferris wheel, and at different seconds his height from the ground could be calculated by these functions. And what's good is that we just don't do a lot of trigonometry. There is a kind of application in this real life. Right now, this is about the height of Tom at different times from the ground. The previous problem, video one, we had seen about the first video that I showed was about the temperature, right? So at different temperatures at different times. So this was the second video I'm making. Hope this helps. And I'll continue for the third one. That will be based on something to do with population. Thank you for watching.